second video on transformations of geometric shapes. Our first video covered translations, or what we called slides. This video today is going to cover reflections, or just like you're looking into a mirror, everything seems a little bit backwards, so we call these flips. Many of the same rules apply to reflections that apply to translations, except that flip part makes everything just a little bit different. So let's get into it right away here. So as a quick review, we're going to go through the vocabulary of each of the terms: pre-image, image, congruent, and similar. And you should already have this written down in your notes. If you didn't write it from the first video, it's important to write it here. But the major key is a reflection is still going to be congruent to, or the image and the pre-image are still going to be congruent to each other for a reflection as well as a translation. So in many ways, the rules of this video are going to be the same as the rules from the last one. So let's jump right into an example. So we have a graph here. We need to know that the image and pre-image must be congruent, or the same shape and the same size with each other, and we know that reflection means flip. So our first shape is going to be a triangle ABC, and we're going to reflect it over the x-axis. And the x-axis is right here. Y-axis is right here. If you make a Y with your body, straight up and down is the Y-axis. If you try to make an X with your body, you can't quite do it, so you get a little tired and lazy, and you create the X there over the middle, or the horizontal axis. So let's figure out what the actual shape that we're dealing with is here. So we have -3, 3, -3, 6, and 0, 6. Let's graph those right away. -3, 3 is right here. We'll put that as point A. -3, 6 is up here, and that'll be point B. And finally, C is right here. Did I miscount? I did. Let's drop B down 1 point here. So there we go. B is right here. That looks a little bit better. And C is right there. And we'll put our lines between them, because it is a triangle, right there. So now the rules for flipping over the x-axis is, we think about the x-axis is right here, and point A is going to flip over the x-axis, and it's going to flip down like this. So if you took a piece of paper and you folded it in half and folded it, you would create the shape on the opposite side. But obviously, since we're on a computer, we don't want to do that. So the trick is that you find your point in the middle, which in this case is the x-axis, so it's right here. And you count the distance away from that point. So for A, we are 1, 2, 3 units away from our point of reflection. So we need to be 1, 2, 3 units away from the point of reflection in the opposite side. So there is our A prime. C prime, by extension, is 1, 2, 3, 4, 5, 6 units away from the point of reflection. So it needs to be 1, 2, 3, 4, 5, 6 away from the point of reflection in the opposite direction. Now, B is 3 units above A here. So B prime needs to be 3 units away from A prime, but in the opposite direction because it is flipped. And there is our new shape. A prime, B prime, C prime. So that means our ordered pairs, A prime is -3, -3. B prime is -3, -6. And C prime is 0, -6. So if we notice in this problem, the x values stayed the same, but the y values became negative. And that will only happen if you're flipping over the x-axis. Now, if we're flipping over the y-axis instead, those rules are going to be very slightly different. So let's graph rectangle LMNO, and then do our reflection over the y-axis this time. So point L is right here. M is right here. Nope, that's not right. M is above. It's right here. There we go. N is right here, and O is right here. So there is our rectangle. And I probably should have put the L on the outside, but that's okay. You usually don't know where you're going when you start the graph. So I'm going to put the L right there. Okay, so now we have our rectangle, and we need to flip it over the y-axis. And once again, if we make a y with our body, that will tell us what the y-axis looks like, which means it's right here through the middle. But we have a problem. Our points O and N are on the point of reflection. So if you remember from the last one, if we were 3 units away in one direction, we had to go 3 units in the opposite direction away from the point of reflection. But here, we are 0 points away from the point of reflection. So both of these points are going to stay where they are because they're going to stay 0 units away. So it's going to be kind of like an anchor, and this is going to flip over it kind of in that direction. So M is 1, 2, 3, 4 units away to the right. It needs to be 1, 2, 3, 4 units away to the left. So there's our M prime. L is 4 units away to the right, so it needs to be 1, 2, 3, 4 units away to the left, and there is L prime. So once again, we have created our shape. Our shape is congruent to the original, so our image and pre-image are still congruent. And if you notice, we flipped over this point. So let's do a one that's a little bit harder. So in this case, we are reflecting the triangle XYZ, which I already graphed for you, over the line y equals -2. And I say up here in nice and red, if they give you a line, graph the line first before you do anything else. And so the line y equals -2, if you remember from our last unit, that means we need ordered pairs where the y value is -2. And the x value can be anything. So that means our y must be -2, -2, and -2. And our x can be any number. So I'm going to pick 1, 2, and 3 just to help me out. So 1, -2 is here. 2, -2 is here. And 3, -2 is here. So we are creating a horizontal line. Whoops. Try that again. A horizontal line through y equals -2, right there. So we are reflecting over this line. So for each individual point, we need to be 3 units away, or for x, we need to be 3 units away. For y, we need to be 6 units away, and z, we need to be 3 units away in the opposite direction. So x, 1, 2, 3, goes down 1, 2, 3, and there is our x prime. Y is 1, 2, 3, 4, 5, 6. So it's going to go 1, 2, 3, 4, 5, 6. And there is our y prime. And so z is 1, 2, 3. So z prime is right there. And we have now graphed our new triangle. And we've done it correctly because these triangles are congruent to each other. They just have a slightly different orientation. So let's do our ordered pairs real quick. X is 2, 1. Y is 4. 1, 2, 3, 4. And Z is 8, 1. So then our X prime is 2, 5, -5. Our y prime is 4, and then -8. And our z prime is 8, and then -5. And the reason why I'm showing you this at the end of the video is, unlike with our translations or our slides where there was kind of a process you could pick, it is much harder to find the pattern to go from one number to the other. Now in this one, I know the pattern ended up working out this way, but it was much easier to do the graph. And for most of the time, when we're dealing with reflections or rotations, if you have the choice, graph the shape and then find the ordered pairs after that when you're done. As always, if you have any questions, please let me know.